Hello, you are welcome. I am Jeti Chawang and I am going to illustrate to you how to draw the cross-sectional profile of a geological map showing the internal structures of the rock layers. For the task, let's consider a geological map. This is a geological map. The problem is to draw the cross-sectional profile of the map showing the internal structures of the rock layers. To complete the task, follow these steps. Begin by identifying where a single bedding plane intersects with a contour line. For instance, let's take this bedding plane that intersects the 400-meter contour at two distinct points. One is here and another one is here. These points are both located at an elevation of 400 meters above the sea level. The line connecting these points is a horizontal line which represents the strike of the bedding plane at 400 meters. Since the strike is always a horizontal line that runs along the same elevation. The same bedding plane intersects the 500-meter contour at three distinct points. One is here, another is here, and another is here. The line joining these points will represent the strike of the bedding plane at 500-meter elevations. Again, the same bedding plane intersects the 600-meter contour at three distinct points. One is here, another is here, and another is here. The line joining these points represents the strike at 600 meters. Continue this process for all possible bedding planes and contour intersections across the map, identifying strikes at various elevations. Since the strikes are aligned in a north-south direction, the strikes of the rock beds is 3.0 degree, that is north. To determine the dip direction, you need to look at a bedding plane that intersects with at least two strike lines. Let's take a bedding plane as an example. This bedding plane intersects this strike, forming the 400-meter strike. It also intersects this strike, forming the 500-meter strike, and this strike, forming the 600-meter strike. As the elevation of the strikes decrease from the west to east, the rock layers are dipping in the east. Since east corresponds to 90 degrees from the north, the dip direction of the rock bed is north 90 degrees. The angle of dip represents the steepness of the rock bed's slope. To determine this, first, measure the average horizontal distance between two consecutive strike lines, which is 2.56 cm on the map in this case. Then, draw a horizontal line of 2.56 cm on a piece of paper. This line represents the horizontal distance between the two consecutive strike lines. Based on the contour interval, the vertical distance between two consecutive strikes is 100 meters, which is equivalent to 1 centimeter on the map. Draw a perpendicular line of 1 centimeter from the right end of the 2.56 centimeter line, since the dip is towards the east. Connect the ends of the horizontal line and the perpendicular to form a right triangle. The angle between the horizontal line and the hypotenuse is the tip angle theta of the rock beds. Using a protractor, measure this angle. In this example, the angle of dip is 21 degree. Therefore, the rock bed has a dip of 21 degree towards the east. To create a profile section, draw a line on the map and label it XY, along which you will draw the cross-sectional profile. It is best to select a line that cuts across the most significant features of the map. Once the section line XY is drawn, fold the map along the line like this. Place a piece of graph paper on a flat surface and write the scale of the map and draw a horizontal line on the graph paper to represent the XY line. Place the folded map over the graph paper so that the folded edge aligns with the XY line on the graph paper. Mark all the points where the XY section intersects contours and bedding planes, as well as the boundary lines. Label these points accordingly. Here, this is the point where the XY line intersects the left boundary of the map. Mark it. Next is the point where the XY section crosses the 800-meter contour. Label this point as I. The next one is the point where the XY line crosses a bedding plane. Label this point as B. Again, next is the point where the XY section crosses the 800-meter contour. Label this point as I. Next is the point where the XY section crosses the 700-meter contour. Label this point as 7. Continue this process for all intersections and label the points accordingly. Once you have marked all the points, remove the map from the graph paper. Using a scale, draw the boundary lines on the graph paper. On the vertical axis of the graph paper, mark the elevation at 100-meter intervals. For example, mark 100 for 100 meters, 200 for 200 meters, 300 for 300 meters, and so on, at 1 centimeter intervals along the vertical axis. Plot the corresponding elevations for each point you mark along the XY line. For instance, for a point that intersects the 800-meter contour, plot it at the 800 mark on the vertical axis. Repeat the process for all other points, such as 700 meters, 600 meters, 500 meters, and so on. Once you have plotted all the points, use freehand to connect the points smoothly. Pay special attention when joining points with the same elevations. Do not draw a straight line between them unless the contour supports it. Instead, refer to the contour pattern on the map. For example, in the map, this point and this one both have an elevation of 800 meters. And the section XY is located inside the 800-meter contours in this particular area. So, the profile should show that this portion is higher than 800 meters but below 900 meters. As the section does not cross the 900-meter contour. Therefore, connect these points with an upward convex curve. Similarly, these 2 points have the same elevations of 500 meters and the section XY lies outside the 500-meter contour. So, they should be joined with a downward concave curve but not reaching 400 meters as the XY line does not cross the 400-meter contour. To illustrate the internal structure of the rock beds, start by marking a point on the XY line and using a protractor make an angle of 21 degrees to the right of the point. Since the dip angle is 21 degrees towards each. Now project the positions of the bedding planes marked as B on the XY line onto the profile. Using a scale, draw lines representing the bedding planes parallel to the lines representing the dip angle, this line. Make sure to connect corresponding bedding plane points. For example, in the map, this point, and this point represent the same bedding plane between shale and limestone. Here it is shale and it is limestone. And here also it is shale and it is limestone. So a single line will pass through these points to represent that bedding plane. Finally, add an index to indicate the different rock types and use different colors or shades to distinguish between the rock types such as shale, limestone and granite. The resulting figure will look like this. I hope you now have a clear understanding of how to draw the cross-section and profile of a geological map showing its internal structure of the rock layers. This is the module. Thank you for visiting my channel.